Why atoms can't collapse. What Feynman found will explode your mind. You think atoms are stable, little planetary systems with electrons orbiting around a nucleus, like tiny solar systems, solid and dependable and permanent. You think the matter you're made of, the chair you're sitting on, the air you're breathing, is stable, because atoms are stable. Electrons orbit, nuclei sit in the center, everything stays in place. That's what you learned in school, right? Atoms are like little machines, running smoothly, keeping matter together, maintaining the structure of reality. But here's what's going to completely destroy your understanding of why you exist, why matter exists, why anything exists at all. Atoms should collapse. Right now. Instantly. Every atom in your body, every atom in the universe should collapse into nothing according to the laws of physics you think you understand. But they don't. And the reason they don't reveal something so strange about the nature of reality that, even now, a century after we figured it out, most people can't accept what it means. Right now, think about what an atom supposedly looks like. You've seen the pictures, a nucleus in the center, electrons spinning around it in neat circular orbits. It looks stable. It looks like it makes sense. It looks like something that could last forever, like a well-designed machine with all the parts in their proper places. But that picture is completely, fundamentally, catastrophically wrong. And once you understand why it's wrong, once you see what atoms really are and why they don't collapse, you'll never be able to think about yourself, about matter, about the nature of existence the same way again. Let me start with a simple question that will break your brain. If electrons are negatively charged and the nucleus is positively charged and opposite charges attract, why don't electrons just spiral into the nucleus? Why doesn't every atom in the universe collapse into a point in about a billionth of a second? This isn't a minor technical problem. This is the fundamental question of existence. Why does matter exist? Why doesn't everything just shrink to nothing under the force of electromagnetic attraction? According to classical physics, according to the laws you learned in school, atoms are impossible, cannot exist, should not exist. Here's why. A charged particle moving in a circle is accelerating. Always. Even if it's going at constant speed, it's changing direction, which means it's accelerating. And according to Maxwell's laws of electromagnetism, any accelerating charged particle radiates energy. It gives off electromagnetic waves, light, radiation. As it radiates energy, it loses energy. As it loses energy, it slows down. As it slows down, the electromagnetic attraction between the negative electron and the positive nucleus pulls it inward. Smaller orbit, faster acceleration, more radiation, more energy loss, tighter spiral. The math is brutal and undeniable. An electron orbiting a nucleus should radiate away all its energy in approximately 10 × 10 seconds. 1/10,000,000th of a second. Every atom in the universe should collapse faster than you can blink. Matter should not exist. Chemistry should be impossible. You should not be here. Nothing should be here. The universe should be nothing but a collection of collapsed atomic cores surrounded by empty space. But you are here. Matter exists. Chemistry works. Atoms are stable. Something is preventing the collapse, something that classical physics cannot explain, cannot predict, cannot even imagine. And that something is so weird, so contrary to everything your brain expects about how reality works, that when physicists first figured it out, they refused to believe their own calculations. This is where Richard Feynman comes in. Feynman understood better than almost anyone that when reality doesn't match your expectations, when the universe refuses to behave the way your intuition says it should, you don't argue with the universe. You change your intuition. You accept that reality is stranger than you thought. And the reality of atomic stability is stranger than anything anyone could have imagined. The solution to the atomic collapse problem came from quantum mechanics. And quantum mechanics doesn't just solve the problem, it completely destroys every assumption you have about how matter works, about how particles behave, about what it means for something to exist in space and time. Are you ready for this? Because this is going to hurt. Electrons don't orbit the nucleus. They don't move in circles. They don't move in ellipses. They don't move at all in any sense that you understand movement. Electrons don't have a definite position. They don't have a definite speed. They exist as probability clouds, smeared out around the nucleus in patterns that mathematics can describe, but your imagination cannot visualize. Here's the first shock. The electron is not a particle moving around the nucleus. The electron is a wave function, a mathematical description of all the places it might be if you were to look for it. But when you're not looking, when you're not measuring, the electron doesn't exist anywhere in particular. It exists everywhere in its orbital simultaneously. It's not that you don't know where it is, it's that it isn't anywhere specific. Location for an electron is a meaningless concept until you force it to have one by observing it. This is not a failure of measurement. This is not about the limitations of our instruments. This is about the fundamental nature of reality. Particles don't have definite positions until you measure them. Before measurement, they exist in what we call superposition, a state where they're in all possible positions at the same time with different probabilities. The electron around a hydrogen atom exists in a cloud of probability that has a specific mathematical shape, but no specific location within that shape. Now here's where it gets really insane. The reason atoms don't collapse is because of something called the uncertainty principle. Werner Heisenberg proved that you cannot simultaneously know both the exact position and exact momentum of a particle. The more precisely you know where something is, the less precisely you can know how fast it's moving. The more precisely you know how fast it's moving, the less precisely you can know where it is. This isn't a limitation of measurement technology. This is a fundamental feature of reality. And here's the key insight that solves the atomic collapse problem. If an electron were to collapse into the nucleus, its position would become very precisely defined. But if its position is precisely defined, then by the uncertainty principle, its momentum becomes completely undefined, which means its energy becomes huge, potentially infinite. The electron would rather exist in a probability cloud around the nucleus than pay the enormous energy cost of being precisely located. The electron doesn't collapse because collapsing would violate the uncertainty principle. The universe won't let it happen. Not because of any force preventing it, not because of any mechanism pushing it outward, but because precise location is forbidden by the fundamental structure of reality. The electron maintains its distance from the nucleus, not because it's orbiting, but because being too close would require it to have too precise a position, which would give it too much kinetic energy, which would make the total energy of the system higher than it needs to be. This gives us a completely new picture of atomic structure. Atoms are not tiny solar systems. They are standing waves. Think of a vibrating guitar string. The string vibrates in specific patterns, specific frequencies, specific modes. It can't vibrate at just any frequency. It can only vibrate in ways that create standing waves, where the ends of the string are always motionless. Nodes. Electrons around atoms are the same. They can only exist in specific wave patterns, specific energy levels, specific orbitals. They can't exist at arbitrary distances from the nucleus. Only certain patterns are allowed. These allowed patterns are what we call electron orbitals. They have names like S, P, D, F. They have specific shapes, specific energies, specific numbers of electrons that can occupy them. An electron in an s orbital exists as a spherical probability cloud around the nucleus. An electron in a p orbital exists as a dumbbell-shaped probability cloud. But in both cases, the electron doesn't exist anywhere in particular within that cloud until you measure it. But here's what's going to really mess with your head. The electron doesn't gradually transition from one orbital to another. It doesn't spiral inward or outward. When an electron changes energy levels, it quantum jumps. It disappears from one orbital and instantly appears in another without ever existing. In the space between, it's like a light switch that's either on or off, never in between. The electron is either in this orbital or that orbital, never in transition. This quantum jumping is why atoms can absorb and emit light at only specific frequencies. When an electron jumps from a higher energy orbital to a lower energy orbital, it emits a photon with exactly the right amount of energy to account for the difference. When an electron absorbs a photon, it can only absorb photons with exactly the right amount of energy to jump to a higher orbital. No other energies are allowed. This is why elements have specific emission spectra, specific absorption lines. Each element has its own unique set of allowed energy levels, its own unique quantum fingerprint. And this brings us to another mind-bending realization. The stability of atoms, the reason you exist, depends on the fact that there's a lowest possible energy state that electrons can occupy. We call this the ground state. An electron in the ground state cannot lose any more energy because there's nowhere lower for it to go. It's stuck, not because of any force holding it in place, but because the mathematical structure of quantum mechanics forbids any lower energy state. If there were no ground state, if electrons could lose energy indefinitely, they would spiral into the nucleus and matter would collapse. The existence of a lowest energy level is what prevents atomic collapse. And this lowest energy level exists not because of classical physics, not because of forces and orbits and mechanical stability, but because of the wave nature of matter and the uncertainty principle. But wait, it gets stranger. The ground state is not a state of zero energy. Even in the ground state, the electron has what we call zero-point energy. It's still moving, still vibrating, still existing as a probability cloud. Even at absolute zero temperature, when all thermal motion has stopped, quantum mechanical motion continues. The electron can never be completely still, can never be perfectly located, because that would violate the uncertainty principle. This means that even in the most stable possible configuration, atoms are not actually at rest. They're vibrating with quantum mechanical energy that cannot be removed. This zero-point energy is a consequence of the wave nature of matter, and it's what ultimately prevents atoms from collapsing to zero size. The electron cannot be precisely located at the nucleus because that would give it infinite kinetic energy. There's a minimum size, a minimum energy, below which atoms cannot shrink. Now, let's think about what this means for your understanding of matter. Everything you are made of, every atom in your body, is held together not by mechanical forces, not by tiny orbits, not by anything that resembles the macroscopic world you experience, but by quantum mechanical wave functions that exist in probability space. The stability of matter depends on mathematical principles that have no analog in everyday experience. Your body is made of quantum waves. Your cells are quantum structures. Your DNA is a quantum pattern. The chemical bonds that hold your molecules together are quantum mechanical phenomena. The electrons that create those bonds don't exist in specific locations. They exist as probability clouds that overlap and interfere with each other in ways that create the illusion of solid matter. But here's the most profound implication of all this. If matter is made of quantum waves, if particles don't have definite positions until measured, if electrons exist as probability clouds rather than point particles, then the boundary between matter and energy, between substance and mathematics, between reality and possibility, becomes completely meaningless. You are not made of solid stuff. You are made of probability patterns that have learned to hold their shape. You are not a collection of particles. You are a collection of wave functions that happen to interfere constructively in a way that creates the appearance of stable matter. You are not separate from the quantum field that fills all of space. You are a localized excitation of that field, a standing wave in the ocean of possibility. The atoms that make up your body are not little machines with parts that fit together. They are mathematical descriptions of how quantum fields interact. The electrons that create the chemical bonds in your neurons, the bonds that allow you to think, don't exist anywhere in particular. They exist everywhere in their probability clouds simultaneously, until the act of interaction collapses their wave functions into definite outcomes. This brings us to another shocking realization. If electrons exist as probability waves until measured, and if measurement collapses the wave function, then what counts as measurement? When does the wave function collapse? This is one of the deepest unsolved problems in physics. Some interpretations say that consciousness causes collapse. Others say that any interaction with the environment is enough. Still others say that the wave function never actually collapses, that all possibilities exist simultaneously in parallel universes. But regardless of interpretation, the basic fact remains. The stability of atoms, the existence of matter, the possibility of chemistry and biology and consciousness all depend on quantum mechanical principles that operate completely outside the realm of common sense. The electron doesn't collapse into the nucleus because reality is fundamentally probabilistic, not deterministic. Here's something that will blow your mind. The size of atoms is not determined by the size of their parts. It's determined by quantum mechanics. The radius of a hydrogen atom, about half an angstrom, is not because the electron is orbiting at that distance. It's because that's the size of the probability cloud that represents the ground state wave function. Change the mass of the electron, change the charge of the proton, change the value of Planck's constant, and atoms would be different sizes. Atoms are the size they are because of the fundamental constants of quantum mechanics. This means that your body is the size it is, that matter has the density it has, that chemistry works the way it works, because of quantum mechanical constants that were set at the birth of the universe. If those constants were slightly different, atoms would be larger or smaller, matter would be more or less dense, chemistry would work differently, and you would not exist. The fact that atoms don't collapse is not a lucky accident. It's a consequence of the deep structure of reality. The universe is constructed in such a way that matter is stable, that complexity is possible, that chemistry can create the intricate patterns we call life. The uncertainty principle, the wave nature of matter, the existence of ground states, these are not obstacles to understanding. They are the foundations that make understanding possible. Let's go even deeper. The quantum mechanical nature of atoms explains not just why matter is stable, but why matter has the properties it does. Why are some elements metals and others gases? Why do different atoms form different types of chemical bonds? Why do elements have the specific properties they have? The answer is always quantum mechanics. The arrangement of electron orbitals, the way wave functions overlap, the specific energies of different quantum states. Carbon forms 4 bonds because it has 4 electrons in its outer shell that can participate in bonding. But those electrons don't exist in specific locations around the carbon nucleus. They exist as probability clouds that can overlap with the probability clouds of other atoms in specific ways. When the wave functions overlap constructively, you get a chemical bond. When they overlap destructively, you get repulsion. All of chemistry is quantum mechanical interference patterns. And here's something that should completely change how you think about yourself. The chemical reactions in your body, the reactions that power your cells, that create your thoughts, that maintain your life, are all quantum mechanical processes. When enzymes catalyze reactions, they're creating quantum tunneling pathways that allow reactions to happen faster than classical physics would predict. When photosynthesis converts light into chemical energy, it's using quantum coherence effects that we're only now beginning to understand. Life is not separate from quantum mechanics. Life is quantum mechanics. But the most mind-bending implication of atomic stability is this. If atoms are quantum mechanical wave functions, if electrons exist as probability clouds, if matter is made of mathematical patterns rather than physical substance, then what does it mean to exist? What does it mean to be real? What does it mean to be you? You think you're made of solid atoms, but atoms aren't solid. You think you're made of particles, but particles don't have definite properties until measured. You think you have a definite location, but you're made of wave functions that exist in probability space. You think you're separate from the universe, but you're a pattern in the quantum field that fills all of space. The boundary between you and the environment is not a physical boundary. It's a mathematical boundary, a place where one set of quantum wave functions transitions into another set. You don't end at your skin. You fade gradually into the quantum vacuum, connected to everything else through the universal wave function that describes the entire universe. This is what Feynman understood that most people miss. Quantum mechanics is not just a theory about atoms and particles. It's a theory about the nature of reality itself. It tells us that the universe is not made of stuff. It's made of information. It's made of possibilities. It's made of mathematical relationships between observations. And you, sitting there reading this, are not a thing observing the universe. You are the universe observing itself. You are a temporary pattern in the quantum field, a localized region where the universe has become conscious of its own existence. The atoms that make up your brain are quantum mechanical wave functions that have organized themselves in such a way that they can contemplate their own quantum mechanical nature. The reason atoms don't collapse is the same reason you exist.